Does someone have an idea? What on earth am I going to do to solve a quadratic, not equation, a quadratic inequality where there's a greater than sign, less than symbol, I gotta do some shading, interval notation? Anyone tell me? Give me some input, then I'll show you what I like myself, which I think is very, very easy to use to get the answer. And this is where the calculus, math 7, they usually start you out with these on day 1. Any ideas? Okay, here's one idea. We solved this one before. Yes, I do see answers what, 5 and -2 coming out if this were an equation. And guys, shoot this graph into a parabola. Is it a quadratic? Let's shoot graph into a parabola. And I think we showed, okay, Professor, if this were an equation, you're going to get 5 and a -2. In other words, you're going to get -2 here, right, out to 5. And Professor, I know those two are on the grid, and like this, as a parabola. And that parabola's got to pick up those two numbers. We discussed that. By the way, should the parabola open up or down, if you recall anything at all about a parabola? Because the parabola could do this. I think the one I did before the break did that. Anyone tell me the difference? How do you know whether it's going to open up like mine did before the break, or is it going to open down? Yeah, if there's a negative sign in front up here, it's going to open down. It's going to be one of these. It opens down. Mine is positive 1, understood? If it's positive, it's going to open up. Guys, a quick sketch is maybe something like this. And say, Professor, that's a rough sketch, that's a parabola. Let that act as a picture of the parabola. A picture of that x squared minus 3x minus 10. Now, we're trying to solve this. And someone in this clever class, I've graphed it for you. So let me step back and look at it. Looks beautiful. Can anyone tell me, to look at the graph, if this were missing, and this had just equal to, we discussed this before the break, equal to say, Professor, if you graph it for me, you're looking for the x-intercept where it crosses the x-axis, and those are the answers. I don't have to factor, I don't have to use quadratic formula, Professor, I got it. So -2 and 5 would be the answers if it were this, equals. No, now it's this. I can just mark it at work. Now, can someone tell me, what on earth are you, I will tell you ahead of time, that graph tells you the answer. Now, can someone be clever and tell me, what would you look at on that graph to see what on earth is the answer for this inequality, not equation? Oh.
Can be either -2 or 5 or more.
A little bit more.
It can be either -2.
Okay, back to there.
Or 5 or more, but not the numbers between -2 and 5.
Okay, I want something else. I heard what you said. I want something else that when you stare at it, and this is like most of these higher level math courses depend so much on graphs. They love graphs. But do you really know what a graph does? Can you read the graph? I'm telling you ahead of time, if I know how to read this graph, I've got the answer to this. Anyone tell me what would I be looking at on that graph to get the answers in a snap and not have to go any further? Let's see, hang one up, yes.
I think it's where the y value is greater or equal to 0. So
Okay, tell me more in terms of my sketch. Oh, you're very close. Tell me more.
it would be negative infinity, including -2.
Okay, tell me, okay, let me stop you there. I got you, the guy's on the right track. Guys, greater than 0. To me, greater than 0 means you're above 0. And says also you could be on 0. So what part of my purple graph is either above or on the x-axis, that's x-axis is actually 0. It says, show me where it's higher than 0, bigger than 0, greater than 0, my graph, or on. Please tell me, I'm putting green, is this the piece here, is this piece greater than, or is it above 0? Is that piece above 0? By the way, guys, is the x-axis acting as 0? Is all that positive? Oh, by the way, does that greater than 0 mean positive? So would it make sense if that's the part of the parabola that's positive, the part that's above the x-axis? Is there another piece that's above that would satisfy this? Is this piece right here also above the x-axis? Those are the pieces that are positive. If you drop down here, what's left over of that purple, that's negative. You're in negative territory down there. They want here, you want to stay in positive. Now, they just kept telling me the answer. Now, they'd like to know by graphing, when is that happening? And he's going to tell me an interval notation. Based on that, he's going to tell me, tell class here on the x-axis, when is that shaded above happening?
So it would be, parentheses, negative infinity, comma -2,
And it's -2 to be included.
bracket, yeah.
Love it. Love it.
And then I forgot what.
Oh, look at this. He said, oh, hold on, Professor, he's good. Don't stop there. This piece over here is also working. Now tell someone, are you guaranteed that's working? Now he's going to tell me.
Would be bracket 5.
Again, I'm going to put union, I use a U like a union, indicate there's another piece to it, union. So one interval, union another, and he's telling me it's bracket 5. And how am I going to end this?
Comma infinity parentheses.
Look at that, mathematician. There's your answer. You're done. Now suppose Ramsey does not give a graph to you. Suppose I do not give you that. And you gotta solve it without the graph. Now before I jump in to show you how to solve and get the same answers without the graph. Hang on just a second here. Now let me do this. Part C, let's throw in part C right above here. Suppose it had looked like this. X squared minus 3x minus 10 is less than 0. Same problem, same graph. Yeah, now indicate, it says less than 0, less than means below. So I like to now go back to my grid over here where I graphed it and show the piece of the parabola where it's below the x-axis. That's what they want this time. When is it less than 0? So here I'm gonna shade, guys, and see if you guys will agree. Is this red shading on the parabola, is all that below, or I sometimes describe this down in negative territory. Is all that below? Is that less than 0? There's the answer. Now be careful. If I say, when is that happening, as he helped me out so nicely with this one, guys, when is this happening? From what to what? How would you describe, how would you tell someone that red is happening when? Give me the answer. I'm trying to tell someone that the red is shaded, and when is that happening? When you're what? The green one was here and here, and he suggested I write like this to show the two pieces. This one in the red has only one piece. Can someone tell me when is that red happening? See it? Yes.
So it should be bracket -2, comma 5 bracket.
Look at that. Bracket, -2. Perfect. Up to 5. Now, you said bracket. I put brackets. I notice I wrote down less than 0, not less than or equal to. So what change should I make? Minor change should be a parenthesis. And there's the answer. Who would have thought that something that looks that challenging back here could be made to be so easy, where you just look at the graph and see when is it above, when is it below, and you answer the question. If the graph is provided to you. Now, on the side here, so when you walk in on Wednesday, I doubt if I have the graph for you. That's one option, but on the side here, let's say you walk in, you wanna do the first quiz, I think that's what you're on for this. And then go back to x squared, subtract 3x, subtract 10, watch carefully. Start out with this. Greater than or equal to 0. And you don't have the graph this time. What am I gonna do? I'm gonna factor, like I did before. It factors merely into this. X minus 5, x plus 2. Now here's the technique. If you don't have the graph provided. A little reminder. We had answers earlier when this was not an inequality, it was an equation. Someone remind me, what were the numbers, the answers earlier? Positive 5 and negative what, 2? Did we have those for answers earlier? So we'll place negative 2 here. Positive 5, now watch carefully. Here. Like we did before the break. In fact, they came up also here. Here's negative 2, and here's a positive 5. Here's on my sketch over there. But this time I'm doing it on a number line, as if that sketch is not provided to me. I'm doing those differently. So I got my answers on the number line. Now what you must do to see where to shade and get the answer, you must check a number to the left of negative 2, a number caught between negative 2 and 5, and a number of your choice to the right of 5. I don't care what number you choose, but you gotta choose some number. I'm gonna show you what we're gonna do with it. Out to the left of negative 2, what's happening to the left of negative 2? I don't know yet. Let's choose a number. You can choose negative 3, negative 1,000, negative 99. It's up to you. I'm gonna try a negative 60. That's my test number. Now you gotta try something in between these two. The guys caught between negative 2 and 5, lots of numbers, infinite numbers. I'm gonna try 0. It's up to you. Out to the right of 5, it's up to you. We'll test 10. That number, test number would be up to you guys. I think I called this, what's this, negative 60? Those are my choices. They said, Professor, what are you going to do? Please tell me you're not going to go back and plug in negative 60 here where I got squared. Negative 60 here where I'm going to do that. And then do all that arithmetic, Professor? No. That would take forever to do the arithmetic with negative 60 squared. That's 3,600 already. No, what we'll do is go back to the factor form. If I replace x by negative 60 right here, would that give me altogether negative 65? Okay, I'm just interested in, I'll put it in red, I'm just interested in the sign. I know it's negative 65, you know it's negative 65, I'm just interested in the sign. If I put a negative 60 here, negative 60 plus 2 is how much? Negative 58. I'm not concerned about the number, it's another negative though. And what in mathematics is a negative times a negative always going to give you? A positive. Please tell me, does that indicate back here that greater than 0, does that imply I'm looking for something positive? If it's greater than 0, does it imply positive? And did I just find one side of my number line here to be positive? That says quickly, immediately, all these will work. And by the way, guys, I did have on this one to be included, darkened in. And I tested, so everything to the left of negative 2 should work. Oh, by the way, did we not get that answer earlier? By looking at the parabola? Now I'm doing something different, I'm getting the same answer. Now, in between may work, I see some of these where the entire number line works. Guys, in between, I'm trying 0. What am I going to do? 0 subtract 5, I know that's negative 5, and I know it's negative. 0 plus 2, that's a positive 2, positive. positive is gonna give me always a negative. Looking back at my original here, is that what I was looking for? It says greater than zero. I'm not looking for a negative, so it says do not shade there. That's a negative result. Out to the right, I'm trying 10. 10 subtract 5, of course it's gonna be a positive. 10 plus 2 is gonna give me a positive 12, looks like. Positive times a positive is gonna give me a positive. And yes, looking back, greater than 0 implies that's what I'm looking for. So I found another interval in which it works, and therefore I'm allowed to shade to show that also works. Now, please tell me, in interval notation, we say this works here. Anyone tell me, what does that look like in interval notation? And I hope you tell me this, I'll do this one for you. Is it negative infinity up to a -2 bracket? Was that the same thing we did back here? Now, is there another piece that also worked? That's where this union comes in, union, to show there's another piece. This piece over here, also a shaded works, and how would I describe that as working? It's bracket 5 through infinity. And I think we got that pretty. There's the method to be used to solve a quadratic inequality. You're going to solve it like a quadratic, factor, find your answers, place them on a number line, and you got your answer. Now, I give a name to this. This is called the method. It's called sign analysis. Sign analysis. Nothing to it. Easily done. Therefore, you need not go back to this. It may not be provided to you. This you can do on your own. The sign analysis to get the answer. And that's an example of an inequality with a quadratic. I'm not quite finished yet before I leave this. I saw something else here I better point out to you guys as well. Looks like this. And this way will be my last one here. Last one, for quadratic inequality. I have, let's see if we're ready for it. Yeah, we're ready for it. X cubed is greater than 4x. You know what I used greater than last time? Let's put less than. X cubed is less than 4x. Solve that inequality. Now, since I may stop with this and move into chapter 1, we'll try to move into chapter 1 here shortly. Can anyone give me a clue as to what you would do first in an attempt to get the answer? And I am not going to graph it for you. I'm not going to do this, because this one's not a parabola. Does anyone have an idea?
Subtract 4x.
Very good.
Subtract 4x.
Okay, move the 4x over because she knows one side's got to be a 0. Somewhere in my work, one side must be 0. I agree with it. Beautiful. Now what? This is a beautiful one that's closed down with. Now what? Factor. Is there a common factor first to be taken out? Let's take out x. If I pull the x out, be very careful. It's going to be x squared subtract what? 4. That's 0. Now, is the factoring complete, or is there additional factoring needed? Does anyone recall anything about x squared subtract 4? Will that break on down? If it does, I'm going to break it on down. Right here, this is classified as a difference of squares. Does anyone recall what x squared subtract 4 will break down into, like that, to finish this up? What do you think it looks like factors? X squared subtract 4.
Plus 2 minus.
I got it. X plus 2, x minus 2. Difference of squares. And that is factored. They say, Professor, I wish, Professor, that you had not put that inequality symbol, you had just put equals. 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 And then when you split these up, you're gonna get zero for an answer, -2 for an answer, and a +2 for an answer. You get 3 answers. No, I turned this into an inequality. So I'm gonna do this, guys, is sign analysis. Number line, yes, my numbers are -2, 0, +2. After you get the hang of this, sign analysis is nice. Not that hard. Those are my answers coming out. Are they to be included or not? The way that it looks, no, it says less than, not less than, or equal to, so they're all open. This one's open, open, open. Now you say, Professor, you call it sign analysis. I think you're gonna do the same thing you done in the last one. That means I've got to be patient on Wednesday, and I gotta test something out here, something in between, something here, to see where to shade, and then we got the answer. The guys, in those intervals, it's up to you. Out to the left of -2, you may stick close by if you wish. I'm gonna try -6, it's up to you. Between -2 and 0, I'm gonna try -1. Between 0 and 2, I'm gonna try +1 to make it easy on myself. Out to the right of 2, let's try 15. Up to you go. Now be patient. Here's where you're going. You're going to replace X by those chosen numbers. Don't crunch out an answer. Just look at the signs. If I replace X by -6, right here, of course I'll start out with a negative. -6 plus 2, my next factor gives me a -4. I'm just interested in the sign. -6 subtract 2 is a -8. I'm just interested in the sign. I didn't mess up, did I? Now what's the negative times the negative times the negative going to give you all together? Negative. So that's it. All that work, and you get, Professor, a result of negative. Please tell me, does less than 0 imply that's what I want? If I say something's less than 0, are we talking about something negative? Yeah, so I discovered immediately, this works. I may shade this, and that's part of the answer. Okay, now let's test -1. Be careful. Replace X by -1, guys, I'm squeezing in right here, it's negative. -1 plus 2 is a positive. -1 subtract 2 is a negative. So I got negative, positive all together, that's what? Is it a positive? Can you guys see all that? So this gives me a positive if I have no mistake. I got a negative, positive, and a negative. Is that what I wanted? No, less than 0 says you want a negative, you can use it. So shade there. 1, I'm testing 1 next. Replace X by 1, of course, it's positive here, squeeze that in. 1 plus 2 gives me a positive 3, no problem. 1 subtract 2 gives me a -1, no problem. A positive times a negative gives me a negative. My result here is negative. Please tell me, is that what I want? And I found another interval that works. You get shade in. I chose 15. Let's see what happens to 15. Replace X by 15, get a positive, of course. 15 plus 2, positive 17. 15 subtract 2, positive 13. What are all those positives going to give me? A positive. And that's not what I'm wanting. I want something less than 0. So I'm finished. That's the answer. The answer to what, Professor? The answer to this. This is the original problem. This is the answer. So guys, what will work here, if we have no mistake, is negative infinity up to, what is it there? -2, open, union. Now someone help me, how are you going to write this one? This also works. How are you going to put this in interval notation? It's caught between what? 0 and, was it 2? 2. And there's your answer. Just where you want to shade. How's that look? We're going to take a little practice. It's called sign analysis. Sign analysis. And more than likely, since this has been introduced to you tonight, and you got a quiz Wednesday, I'll have on the one on the quiz, I'll have on the side there, use sign analysis typed in, so you know you do this to get the answer. Looks pretty good, guys? So I think what we call the basics and the basic skills, took me a little time, I think it's done. We solved equations, we solved inequalities. I think we're now ready to start the course. Now, I used to teach at a university, and we had 55,000 students. And when I was teaching there, how I did it, I'll never know, because I just thought about that problem finished up there. I had in a class, 150 students. One class. They met in an auditorium. And here I was with, I think I had 3 or 4 TAs, I think, who were in that auditorium with me, so they could go through and help students out. And here I was up front with cameras on me and all that stuff, so those in the back could see me, teaching the course to 150 students. Madness. Madness. And then here I am on edge, because if I do something like this, and I make a little mistake with 150 students, you just don't make mistakes. The instructor just does not have the time to say, oh, I'm sorry, I thought you had 150 students in that auditorium. And test day, we break up into groups. One group took their test this day, a second group took their test another day. I had to write separate tests, different tests for all of them. Madness. So at least we have this, which I think is very convenient to do these problems here. Guys, I'm done with this, we're finished. We're not finished with the night. Did they send you guys an email this weekend about the math2 class? Ramsey's math2 class has been extended until 8 o'clock? Oh, they didn't send that out? I put a request in. The president of the college, I gotta talk to her. I requested, that class, I'll give another little 5-minute break. You're gonna be staying till 8. So that's for 8:30. Okay, 7:25 is when we'll go. I'll be here a little bit after 7:25, if you guys have some questions. Now guys, that's done, in the little time I have, Anna? Mr. Park's busy with the, recording. But Anna, everything I need here. Guys, when you look at this is a beautiful, beautiful, beautiful recap of what we basically have done. I've actually written out the quadratic formula. I gave you some hints here, and there's some examples there to work. And then on the back, finally the course starts. It starts out with functions. Now, you don't have easy compared to the shock of, all of a sudden you walk in and you see sign analysis. You see a quadratic inequality. Professor, really? And solving equations and doing all that. Then all of a sudden chapter 1 starts out with functions, and you're gonna love it. Love it. You see what they're asking you to do. Okay, so if we can get through this next part is going to be very, very easy for you. Anna, my dear, would you do me a favor and pass these out? I think I brought enough copies in.